It says A and B are events such that the probability of A is 0.38 and the probability of not B is 0.77. I want us to pause there for a moment. You guys remember complementary events where like two events are complementary when A the probability of A and B gives us an answer of 1. Ne? So if someone comes and says, what is the probability of A complement? Ne? So it's A, but it's got this 1 at the top like this. A complement means anything other than A. So it just basically means B, the other event. Okay. If someone says, what is the probability of B complement? It means that anything other than B, the probability of anything other than B, and that makes it automatically A, the other event. Okay. So now this not B just means B complement. Ne? It means B complement. So yeah, that's what it means. Not B just means could also could basically mean A. But let's continue and see what we get there. So it says A and B are events such that probability of A is 0.36, probability of not B is 0.77, then the probability of A or B is 0.425. So guys, tell me, what is the probability of B from this? What is the probability of B? The probability of not B, B complement 0.7, what is the probability of B? Yeah, so it's 1 minus 0.77, which is 0.23. Who doesn't get this? Okay, proper stuff. The probability of A or B is 0.425. Calculate the probability of B. Probability of B is just 1 minus 0.77 as we've done already. That's 0.23. Easy probability. And what is the probability of A and B? You guys remember I told you you must know this classical formula for probability. Probability of A or B, remember that you can represent this as U. This represents or. Okay, that's what it means. Then the probability of A or B is equal to probability of A plus probability of B minus the probability of A and B. Do you guys see that? Now, you are looking for what probability? You're looking for probability of A or A and B. This is the probability of A and B. This is the same thing. And means this thing. Okay, fair. So now let's substitute now. What is the probability of A or B? Let's talk. Proper stuff. What is the probability of A? Proper stuff plus probability of B. 0.23 minus, this is what you're looking for, probability of A and B. Remember, this means end. End. This thing means end, and this one means or. This thing means or. Okay, so let's calculate 0.425 equals, what is 0.38 plus 0.23? What is 0.38 plus 0.23? 0.61, is that correct? All right, so remember that we're looking for the probability of A and B. So since this is minus here, we could just take it to the other side so that it's positive. And then we just take this one to the right hand side so that it joins the other number and becomes negative when it goes to the other side. Therefore, the probability of A and B equals how much? Can you guys tell me? 0.185. Proper stuff. Can you guys tell me, are events A and B mutually exclusive? Why? Yes, yes. Because the probability of A and B is not equal to zero. So this is just an additional question that I'm just making up. So A and B events, A and B are not mutually exclusive. Exclusive. Exclusive because the probability of A and B is not equal to zero. If this probability is equal to zero, then we would say that the two events are mutually exclusive. Do you guys remember the two conditions essentially for mutually exclusive events? I've touched on them. Where did I touch on them? There. So if they ever ask you if two events are mutually exclusive, you can either prove this, check this, or that. Okay. The probability equal to zero, then you can say yes, they are. Or you must compare the probability of A or B, the probability of A plus B. Let us test this second condition and see if it works. Remember that you can use either one. You can use this one we just used, or you can use the second one. Let us now check. Let's use the second condition. That is, we are checking if the probability of A or B is equal to probability of A plus the probability of B. Okay, this is given. The probability of A or B is given to be 0.425. Okay, Fere. Now you're going to add these two probabilities and see if they give you 0.425. If they give you 0.425, then you can say that the two events are mutually exclusive. Okay, let's see if that is the case. The probability of A is 0.38, while the probability of B is 0.23. This gives an answer of 0.61, which is not equal to um, 0.425 as expected. So therefore, the two events are not mutually exclusive. Do you guys see the two methods for checking whether two events are mutually exclusive? Proper stuff, proper stuff. Okay, I'm gonna save this as well. It's not a long